right. Okay, so today I'm going to be talking about the effects of hearing loss and aging on the electrophysiological masking level difference. First, I'll just be talking briefly about what the masking level difference is, a literature review, the purpose of the study, methods, results, conclusions, and then limitations and future directions. So what is the masking level difference? It's a measure of the ability of the auditory system to separate target signals from background noise using timing differences. So we do this by looking at difference in thresholds between two conditions, the SONO condition and the SPINO condition. The SONO condition would be if you look at the frowny face, and this is when the signal and the noise stimuli are in phase between the ears. So if you can see, the waveform is exactly the same in the right and the left ear. And then if you look at the happy face, that's a SPINO condition, and this is when the signal stimulus is out of phase between the ears, and then the noise is the same between ears. So the waveform flips between the right and the left ear. So it should be easier to hear the signal and noise. The clinical significance for this is that it can be used to identify and evaluate auditory processing disorders and neural pathologies in the auditory system. So how is it measured? It's most commonly measured behaviorally, but it also can be measured through electrophysiological measures. So what we would do is that you have the noise at the same level and you're changing the stimulus, and you're trying to find the lowest level that they can still hear the stimulus before it's just noise. So behaviorally, you ask the participant, I had them have a remote in their hand and to hold the button down as long as they heard the signal, and once they heard only noise, to let go of the button. And then we would switch the phase and do the same thing for the SPINO condition, and then you just subtract those two thresholds to get the MLD. And then through electrophysiological measures, you're doing the same thing. However, they're not responding and they are staying awake and sitting still. And then we are looking at the late potential. So we're looking at the P2 values and just finding the lowest level that P2 is still there. So research out there says that adults with presbycusis had smaller 500 hertz behavioral MLDs than compared to young adults. And this is consistent with decreased sensory or neural function caused by aging. It is also most common to use 500 hertz to elicit the MLD. Elderly adults who complained of speech understanding in noise with near normal hearing had significantly smaller behavioral masking level differences compared to young adults. So this suggests that there is a difference independent of their hearing status, and they use 500 hertz and also speech stimuli. And then in our lab, Lowe found that as age increased, the EMLD decreased for 500 hertz. The decreased MLD could be due to a loss of neural synchrony, causing them to have difficulty with temporal cues. So Emily Wilson in the lab, she looked at 17 young normal adults, and she wanted to see if we could do this, find the EMLD with speech tokens. So she looked at 5 different speech tokens, ah, da, di, ta, and wa. And she found that it is possible to elicit MLDs through evoked potentials. She found that the behavioral MLDs were more robust with ah and wa, and then the electrophysiological MLDs were most robust when elicited with ah. So if you just look at these graphs, the masking level difference, the dark red is evoked potentials and the yellow is behavioral. And as you can see, it is bigger. There's a bigger MLD for the evoked potentials. And then the thresholds, it's broken up on the bottom between the speech tokens. The red and the orange are the evoked potentials, and it's SONO and then SPINO. And then the green is the behavioral SONO and SPINO. And also, the thresholds are greater for the evoked potentials in the same condition. So the evoked potential SONO is greater than the behavioral SONO. So the purpose of my study is to investigate if the speech stimuli can be used to measure the EMLD and BMLD in older adults to try to reflect a more natural listening situation than with the 500 hertz tone stimuli. It was also to investigate the relationship between the BMLD and EMLD in older adults with near normal hearing and hearing loss obtained with 3 speech tokens, ah, da, and wah. We decided to use ah and wah since those were the best results in the previous study, and then we just added da to get some more speech characteristics. And then lastly, we wanted to investigate the relationship between BMLD and EMLD with speech understanding and noise and cognition. So for my methods, this study was approved by the IRB. We had 17 older adults, and they all filled out a consent form. The questionnaires, they filled out a full case history, a hearing handicap inventory for the elderly, and then the Montreal Cognitive Assessment. So we screened to make sure that they had normal cognition for this portion. We did a full hearing evaluation with air and bone. And then for the results, we just averaged out what we got for each ear for 501,000 to be the low frequency average and 2,000 and 4,000 to be the high frequency average. And we did a speech and noise testing. We used the SPIN. This is 50 sentences in each ear with a 8 dB signal to noise ratio. It gives low and high probability sentences. So some sentences, context can give you the answer, and then others, the sentence makes no sense, so you have to really hear what the word is. And for our analysis, we just looked at the low probability scores. Then we did the behavioral testing and the evoked potential testing. So for my demographics, only 12 people were able to complete the full protocol. They were between 52 and 85 years old with an average of 72, not 17, 72. And there's 3 males and 9 females. This is just a graph of their hearing thresholds, so the averages and then the standard deviation. So there were a few adults that had near normal hearing. And then the MoCA scores, like I said, we wanted them to have normal cognition, so greater than 26. So this is a picture of what the evoked potentials looked like. The SONO and then the SPINO, and if you can see, you just follow the P2 down until it's not there anymore. So for my results, we looked at wah, ah, and da. The red and the orange is the evoked potentials, and the green is the behavioral, and then it goes SONO, SPINO, SONO, and SPINO. So again, the evoked potentials are showing greater thresholds than behavioral thresholds. And if we pull up the young normals alongside, it's exactly the same scaling, and you can just see that the older adults had greater thresholds. For the masking level difference, again, the wah, ah, and da on the bottom, and then across is the MLD and dB SBL. So this was just subtracting the 2 thresholds, or the 2 conditions. And again, the evoked potentials are greater than the behavioral masking level differences. And then if we pull up the young normals also are greater than the older adults. And then for our analysis, we really just focused on the wah. If you can see, the da wasn't really giving us a masking level difference. The greatest was 2, which is just 2 dB, so that's not a masking level difference. And then wah, we had the most participants numbers for this group. So this was looking at 9 of the findings. So we did find some significant findings with wah. There was a significant correlation between the auditory evoked potential thresholds and a low frequency average thresholds. So another way to say this is as the thresholds increased, the low frequency average increased, so their hearing was worse. We were expecting to find this since the masking level difference is elicited through the low frequencies. There was a significant negative correlation between the right spin scores, so the speech and noise scores, and the behavioral and auditory evoked SPINO and all hearing thresholds. So it's kind of interesting. We did not find any significance with the left scores. We are not sure why. We did flip every participant. It would change. One would have do the left ear first, or one would do the right ear first. So I'm not sure why, and we have to see when we have more subjects that this continues. And again, just another way to say this is as the percent of the speech and noise results increased, so as they got better, the thresholds and hearing thresholds decreased. And then there is no significant finding for the MLD, but the S-piano is what creates the MLD, so we're hoping with more participants that we will find more significant findings with the MLD. And we also found a significant correlation between the behavioral and auditory evoked thresholds and the HHIE scores. So this is a questionnaire to rate how they feel their hearing handicap is. So as their hearing handicap scores increased, so they felt more handicapped, the thresholds also increased. So for conclusions, we found it is possible to measure the MLD with speech tokens and in older adults. We found ah and wah had the best results, and we would not do da in the future. And then we found that the electrophysiological MLDs are more resilient to aging and hearing loss than behavioral MLDs are, so we got greater responses. So for limitations, it's a small sample size. Also, the protocol is very long. It was 2 sessions of about 2.5 hours each, so it was pretty difficult to have older adults be able to sit still and stay awake. We let them watch a movie, but still I would find some of them snoring, so I had to remind them to stay awake, and then, so that was pretty difficult. For future directions, we need more participants. We should not use DA. We should maybe try to shorten the protocol. And then we want to look at how cognition plays a role, and then look more into the relationship between the young and older adult results. Right now, we don't have enough participants to do that. So these are my references. And I want to thank Dr. Fowler. She spent probably over 30 hours helping me with everything. 6 hours just calibrating the system, so thank you. Emily Wilson and So Park helped me tremendously. And then I want to thank my committee, Dr. Sara Misurelli and Jane Elliott. So any questions? Okay, yes. I was excited, okay.
I was wondering if you can talk at all about the clinical implications of testing the masking level?
Yeah, so I mean, right now, testing it this way, we're still kind of trying to figure out if it is a good way to test. It does take a while. It probably took an hour just to do one speech token. So I think we have to figure that out. And then we also, yeah, I think it's still to be determined, but right now behaviorally, I believe they use it for CAPD testing as part of the protocol, but I'm not sure how we would implement the electrophysiological part of that. So yeah, anyone else? Okay, thank you.